Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. A structured troubleshooting methodology doesn't just save time, it makes the entire diagnostic process more reliable. When technicians follow a defined sequence of steps, they reduce the chance of overlooking key information or wasting effort on guesswork. This structured approach also translates directly to better exam performance, where questions often reward methodical thinking. In the real world, using a consistent process builds muscle memory and confidence. In a testing environment, it improves accuracy under pressure by giving you a repeatable formula to approach each scenario. One of the most effective ways to prepare for troubleshooting questions is to revisit the entire method from beginning to end, understanding each phase of the process not just in isolation, but as part of a larger flow, reinforces your ability to tackle any problem, no matter how obscure. This review also helps you recognize tool outputs and common patterns more quickly. The goal is not just to memorize facts, but to develop the ability to interpret signs, apply tools, and work through the problem with confidence. This final session ties everything together and delivers the last push before the exam. The troubleshooting process always begins with identifying the problem. That means gathering as much information as possible. Talk to users, review logs, check indicators like LED lights, and examine the overall environment. This is the step where symptoms are defined, affected systems are listed, and the scope of the issue is clarified. Without this foundation, it's easy to chase the wrong problem or apply an inappropriate fix. Documentation from this phase sets the tone for everything that follows. Once the problem is defined, the next step is to establish a theory. This means thinking about the most likely causes based on the symptoms. Obvious issues like disconnected cables, full disks, or offline services should be eliminated first. Then, apply your technical knowledge to narrow down possibilities. For instance, if clients can reach the gateway but not the internet, DNS might be the culprit. This phase involves applying judgment, not guessing randomly. The better your theory, the less time you spend testing wrong ideas. After developing a theory, it must be tested. Use commands, tools, or configuration changes to see whether the theory holds up. If you think an access list is blocking traffic, run a show access list command and test reachability. If you suspect DHCP failure, try ipconfig or show ipdhcp bindings. If behavior changes after the test, the theory may be correct. If not, refine the theory or develop a new one. This phase validates your assumptions and helps move the process forward with data, not speculation. Once the theory is proven, create a detailed action plan. That plan should outline what you'll do, how you'll do it, and what to do if something goes wrong. If end users will be affected, notify them in advance, estimate the time required, and plan for rollback in case the fix introduces new issues. Creating a plan helps coordinate teams and minimizes disruptions. It also ensures that changes are made in a controlled, predictable manner rather than on the fly. Next, it's time to implement the solution. Make the necessary changes carefully, step by step, while monitoring system behavior. This might involve reconfiguring a switch port, restarting a service, or removing a problematic firewall rule. If something unexpected occurs, be ready to revert. Always watch for side effects and avoid introducing new issues while solving the original one. This phase emphasizes caution and control, ensuring the solution has the desired effect. After the fix is applied, verify that the entire system is functioning correctly. Test not only the immediate component, but also other systems that interact with it. Ask users to confirm that services are restored. For example, if a VLAN assignment was corrected, verify that devices in that segment now get DHCP leases, reach required services, and no longer experience slowdowns. Full verification ensures the issue is resolved across the board and not just on the surface. With everything working, the final step is documentation. Record what was done, why it was done, and what the outcome was. Update any relevant network diagrams, ticketing systems, or configuration repositories. Documentation is critical not just for future reference, but also for improving team collaboration. It creates a knowledge base that can be used to prevent similar issues, train new technicians, and reduce resolution times the next time the same symptoms appear. Troubleshooting becomes faster and more effective when you start recognizing recurring patterns. VLAN mismatches, speed or duplex conflicts, and cabling faults are among the most common causes of connectivity issues. Configuration errors involving DHCP, DNS, or firewall rules often present as partial access or strange delays. Learning to associate specific symptoms with these root causes helps you focus on the right layers and tools quickly without unnecessary detours into unrelated areas of the network. Knowing how to use diagnostic tools and interpret their output is essential. Ping and traceroute reveal reachability and routing behavior. Show commands provide visibility into configuration status, interface statistics, and device performance. Packet captures uncover deeper protocol issues, while syslog entries provide historical clues about system events. The ability to read and interpret this output separates those who guess from those who diagnose. These tools are your best allies when theory alone isn't enough to identify the issue. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Troubleshooting questions on the exam require more than memorization. They test your ability to apply structure and logic under pressure. Begin each question by reading it fully before jumping to conclusions. Identify the symptoms, note what systems are involved, and look for clues in the phrasing. Questions may include keywords like suddenly or intermittent, which help define the timeline or trigger of the issue. Once the scenario is clear, apply the 7-step method mentally to narrow down the likely causes and identify the correct answer. Many candidates make avoidable mistakes during the exam by skipping fundamental checks. Overlooking link lights, failing to verify interface status, or misreading DHCP settings can lead to incorrect assumptions. Another common error is confusing DNS resolution problems with general IP connectivity issues. Always verify basic functionality before exploring advanced configurations. These missteps often stem from test anxiety or overconfidence, but a structured mindset helps avoid them. Stick to the process and confirm the basics first. The OSI model remains a valuable tool for structuring your troubleshooting path. Starting from the physical layer and working up is often effective when the problem appears to be connectivity. For more complex issues, starting from the application layer and working down may reveal misconfigurations or firewall blocks. Whether you use a top-down or bottom-up strategy, the key is consistency and logic. Guessing without data wastes time and introduces new confusion. The exam rewards deliberate analysis, not gut reactions. Each tool has a purpose, and matching the tool to the scenario is critical for effective troubleshooting. For packet loss or connectivity issues, ping and syslog data often provide the first clues. If traffic is taking the wrong path, traceroute or a showroute command can expose routing anomalies. If users can't reach a service, verify access control lists, interface states, or port security settings. The ability to associate a symptom with the correct diagnostic command is a skill tested frequently on the exam and used daily in real-world roles. Some network issues, particularly those involving design flaws or misconfigurations, relate to deeper architectural concepts like asymmetric routing or switching loops. Asymmetric paths can disrupt stateful firewall behavior because return traffic doesn't follow the expected path. Switching loops generate broadcast storms that cripple local segments. Recognizing symptoms like duplicate packets or high CPU usage on switches can help diagnose these problems. Understanding how these design flaws present helps you make sense of strange behavior and apply the right corrections. Time management during the exam can make or break your performance. Don't get stuck on a single question that feels unfamiliar or overly complex. Flag it and return later if necessary. Use the process of elimination to rule out clearly wrong answers, and then choose the best remaining option. Reasoning your way through the question is more effective than rushing. Even on challenging questions, applying your troubleshooting methodology can reveal the most likely root cause or eliminate distractions. Troubleshooting methodology delivers benefits beyond the exam. It builds the kind of problem-solving reflexes that technicians rely on in the field every day. Using the 7-step process ensures that problems are solved completely, communication is maintained, and root causes are identified, not just symptoms patched. It reinforces careful thinking, consistency, and technical discipline. These habits reduce downtime, improve service quality, and increase your reliability as a network professional. By this point, you've reviewed every phase of the process, including how to gather data, interpret tool output, match symptoms to causes, and document outcomes. You've practiced thinking across layers, understanding tools, and managing both technical and procedural aspects of network diagnosis. This structured method is your advantage on the exam. It works because it gives you a logical framework for every problem, rather than forcing you to guess. If you follow the process, you'll stay focused and make informed decisions under pressure. As you approach exam day, confidence comes from preparation and method. You don't need to know every possible error message or memorize every protocol nuance. You need to know how to approach each problem calmly and methodically. The steps are clear: identify, theorize, test, act, confirm, document. Trust in the structure, and the correct answer will often emerge naturally. The methodology has been tested over time, and it works, not just in the test center, but on the job as well. The goal of this preparation has been to build your understanding of the full troubleshooting process. You now know how to identify problems with clarity, develop working theories, test with precision, and implement solutions with care. You understand the importance of confirmation and documentation. You're able to interpret tool output and match errors to real-world problems. With this foundation, you are not only ready to pass the certification, but also equipped to troubleshoot confidently in any network environment. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.